Let's take a trip and visit one of the most curious planetary systems ever discovered, the TRAPPIST-1 system. It's only about 39 light-years away, in the constellation Aquarius. Not that far, right? It's a really small star, an ultracool dwarf, with less than 10% the mass of our Sun. It barely shines, but even so, it has 7 rocky planets orbiting around it, and 3 of them are in the habitable zone. Yep, the zone where there could be liquid water, and maybe life. These planets were discovered between 2016 and 2017 by the TRAPPIST telescope in Chile, and later confirmed with observations from the Spitzer Space Telescope. Since then, they've become the favorites of scientists who study exoplanets. So here you can see the dwarf star, and here you can see the 7 planets orbiting around it. If I speed up time a bit, you'll get to see how the rotation works. Now we're going to visit each one of these planets, starting with TRAPPIST-1b. This one's the closest to the star, as you can see, and yeah, it's hot. Like, really hot. Its orbit only takes a day and a half. That's like if a year on Earth lasted just 36 hours. And even though the gravity is similar to Earth's, the surface can reach over 400 degrees C, which makes life here very unlikely. Now let's hop over to TRAPPIST-1c. It's also really hot, but it might have a slightly thicker atmosphere, kind of like Venus. Still, doesn't seem like a very cozy place to set up camp, right? Now let's head to TRAPPIST-1d, and now things start to get a little more exciting because we're officially in the habitable zone. It gets a bit more energy than Earth and could have water, depending on its atmosphere. It's smaller than Earth, about the size of Mars. Now we're heading to TRAPPIST-1e. This one is the astronomer's favorite. It's the most Earth-like in terms of mass, size, and temperature. If it has an atmosphere protected by a magnetic field, it could even be a strong candidate to host life. Now let's move on to TRAPPIST-1f. This one's much colder, but still within the outer edge of the habitable zone. It might have an icy crust with underground oceans, kind of like Jupiter's moons. If there's methane or CO2 in the atmosphere, it could trap enough heat to keep liquid water around. Next up, TRAPPIST-1g, a bit of a small giant, almost twice Earth's radius. It's probably really cold, but it might have amazing auroras because of how it interacts with the star's magnetic field. And our last visit, TRAPPIST-1h. But don't worry, the video's not ending just yet. I'll still talk about what it would be like to actually stand on one of these planets and whether life could exist on any of them. But not the kind of life you're probably thinking of. This one is the farthest from the star, and also the most mysterious. We barely know anything about it, but it might have geothermal heat inside, maybe pockets of water. So yeah, there's definitely potential. Now just imagine, what would it be like to stand on the surface of TRAPPIST-1e? The sky would be this dark reddish color, kind of like an eternal sunset. The TRAPPIST-1 star would look big, but way dimmer than our sun. And the craziest part? Since the planets are super close to each other, you'd see giant neighboring planets in the sky. The gravity's pretty close to Earth's, so no moon jumps here. But time, yeah, that would be completely different. A year there lasts just 6 days. And more than that, these planets are tidally locked, meaning the same side is always facing the star. One side lives in eternal daylight, the other in total darkness. The region in between, called the terminator, might have the ideal temperature for life. Not too hot, not too cold. That's exactly where scientists are betting. It could have melted water, rivers, lakes, maybe even life. Plants that absorb infrared light, or organisms that can survive in extreme heat or cold, kind of like the extremophiles we have here on Earth, you know? And since we're already talking about life, let's dive deeper into that idea. When scientists talk about astrobiology, they often think about planets like TRAPPIST-1e. With water, the right pressure, and atmosphere, all of that massively increases the chances of life showing up, even if it's just microbial. On Earth, these beings survive in extreme conditions. At the bottom of oceans, miles beneath the surface where sunlight never reaches, in sulfuric acid lakes, in Antarctic ice, in toxic caves, even in the clouds of our own atmosphere. These organisms are called extremophiles, and if they can survive here, it's plausible to imagine that something similar might exist on distant exoplanets. Take TRAPPIST-1f, with its icy crust and potential subsurface oceans. This setting closely resembles Europa, one of Jupiter's moons. Europa holds more liquid water than all of Earth's oceans combined, covered by a thick layer of ice. Something similar could be happening on TRAPPIST-1f, a dark, deep ocean heated by geothermal energy from the planet's core, with hydrothermal vents releasing heat and essential chemicals. Now, intelligent life, that's a whole different thing. That kind of evolution needs billions of years of stability. But TRAPPIST-1 is 7.6 billion years old. It's older than our sun. So, yeah, those planets had time to evolve. Who knows if an ancient civilization once lived there? The TRAPPIST-1 system is like a reminder. The universe is full of questions, and every planet we discover might be a new chance to answer one of them, or come up with even better questions. Because what drives us isn't the answers, it's the questions. If you liked this kind of content, drop a comment with what you want to see next here on the channel. Thanks for coming along on this journey with me, and see you on the next trip.